The function f from R to R is defined as follows. F of x is equal to e to the power negative 1 upon mod x not equal to 0 and is equal to 0 when x is equal to 0. Then f is differentiable and its derivative is continuous. F is nowhere continuous on R. F is continuous but not differentiable. F is differentiable and its derivative is not continuous. This came in 2021 second shift. Okay, 2021 second shift. Alright, let us go to the function. Function is e to the power negative 1 upon mod x when x is not equal to 0 and it is 0 when x is equal to 0. Okay. Now as usual we will do it the mod way, so it will be e raised to 1 upon x for x positive and it would be e raised to 1 upon x for x negative. Okay. Now let us go to option B first. B is wrong because they are saying it is nowhere continuous, but without investigating for the continuity of this function at 0, we know that it is continuous at least let me put it this way, it is continuous at least when x is not equal to 0. You take any other point, the function will be well defined, right? So B is wrong. Now let us see whether the function is continuous at x equal to 0. Okay, let us check if f is continuous at x equal to 0. We can argue like this. Look, let us find RHL first. Okay, now if x is positive, okay, if x is positive as x tends to 0, what happens to 1 upon x? 1 upon x tends to infinity. What will happen to negative 1 upon x? Negative 1 upon x will tend to negative infinity, and therefore what will happen to e raised to negative 1 upon x? It will tend to 0. Okay, have you understood this? If x is large, okay, sorry, if x is positive, 1 upon x will be also positive, and if x approaches 0, 1 upon x will tend to infinity, negative 1 upon x will tend to negative infinity, and e raised to negative 1 upon x will tend to 0. Okay, so RHL is 0. So at least it is continuous from right. Now is it continuous from left also? Let us argue like this. If x is negative and x approaches 0, what will happen to 1 upon x? 1 upon x will clearly approach negative infinity, and therefore e raised to 1 upon x will approach 0. Therefore left hand limit will also be 0, so therefore it is continuous everywhere. Okay, it is continuous everywhere. I don't see any problem regarding the differentiability of this function at non-zero values. You know how to differentiate it, isn't it? Okay, so let us investigate for its differentiability at 0. Okay, let us investigate for its differentiability at x equal to 0. Okay, at x equal to 0. Let's use first principle. Limit as h tends to 0, f of h minus f of 0 upon h. F of 0 is 0 because we have looked for it. Limit as h tends to 0 plus, what will be f of h then? E raised to negative 1 upon h. Okay, so I can say let 1 upon h be t. Okay, I can say let 1 upon h be t. Therefore as h tends to 0 plus, t will tend to infinity. I definitely know that. So I get limit as t tends to infinity e raised to negative t into t. Great. Now I can apply L'Hospital here. Okay, now I can apply L'Hospital here. It will be 1 upon e raised to t, and that will be 0. Yes. So right hand derivative is 0. Okay, right hand derivative is 0. And okay, can we find left hand derivative in a similar way? Okay, let us see. Let us see if we can find the left hand derivative. F of x is e raised to 1 upon x. Okay, so limit as h tends to 0 minus f of 0 plus h, so it's e raised to 1 upon h minus f of h upon h. Okay, again I can make a change. I can say as h tends to 0 minus h will tend to 0 plus. So let me say let minus h be u. Okay, so limit as u tends to 0 from right, this will be e raised to negative 1 upon u upon negative u. But see, one of our limits here is exactly the same thing, e raised to negative 1 upon h, and that limit was 0. So this will also be 0. So both LHD and RHD are 0. Okay, so differentiable at 0. Whew, okay, so at least we have proved that it is differentiable at 0, and also of course it is differentiable everywhere, so not differentiable is also not not true. Now we have to see whether its derivative is continuous. Now how to check whether its derivative is continuous? Go back to the derivative, left hand right hand derivatives, and evaluate their limits. Okay, that is limit as x tends to 0 plus this one see, look here, for this also I can use the substitution 1 upon x tending to infinity. Okay, so it will be t squared upon e raised to t, this will be 0, right, by the same logic as t upon e raised to t was 0, and similarly x tends to 0 from left, there we have got I think 1 upon x into negative 1 upon x squared, and that would be how much? Again we can bring in those changes. Okay, again we can bring in those changes, and okay, let me write it. Suppose I say that negative x is v, so v tends to 0 plus e raised to negative 1 upon v into negative 1 upon v square, and that's basically the same as this except the negative sign, so this will also be 0, so the derivative is continuous.